Let us practice. Now remember, these examples level up. So you'll do number 1, and then number 2 is a bit more complicated. Also try to see how's the second example different to the first one. So this is a real thinking exercise. So we have to simplify this expression. We see it's a quotient expression. So we can use the distributive property. Like, I think it was also Zoot's method. So instead of saying dividing by x, we multiply by 1 over x. I don't know, but this for me is a bit tricky because then I work with fractions. I would rather split this term or this expression into 2 separate terms. So 8x squared over x and 3x over x. And then simplify each expression separately. So 8, and then if we divide x squared by x, it will just be x. These x's will cancel. It doesn't give you 0, it just gives you 1, but you don't have to write the 1 because 3 times 1 is 3. And we end with 8x plus 3. But be careful, since we started with a quotient expression, and since x is in the denominator, x is 0 is not admissible in this case. So you have to add that to your answer. In example 2, how's this different to the previous one? Let's see, the previous one, this one has got x squared in the denominator. So let's take this quotient expression. We use a distributive property, and that means that it is the same as 8x squared divided by x squared plus 3x divided by x squared. So we took this expression and we separated it into 2 different terms. And now we'll simplify each term separately. So in the first term, it will be 8, because x squared divided by x squared gives you 1. And in the second term, be careful. This is why it's level 2, because there's more x's in the denominator. So one x will cancel, but there will be an x that's left in the denominator. So 3 over x. If you use your laws of exponents, 1 minus 2 is negative 1. And as soon as the x has got a negative 1 exponent, we know it must be in the denominator. Okay, are you ready for level 3? Oh, but we've almost forgot this. Since x is here in the denominator, x cannot be 0. Level 3. Oh, I knew he's going to do that. He always does that. Okay, I'll prove it. So we did simplify this expression to this expression. So to prove that the 2 expressions are really equivalent, let's use substitution. So let's choose x is negative 1. So in this expression, we are going to substitute negative 1 for x. Remember to put the negative 1 in brackets, that's essential. The same here. So now we have to follow order of operation. Negative 1 squared becomes a positive 1. There you go. And 8 times 1 is then 8. 3 times negative 1 is negative 3. And in the denominator, the negative 1, if we put in brackets square, becomes a positive 1. 8 minus 3 is 5. Good. Now let's check our simplified expression. So all we need to do here is put x, the negative 1 here, in the place of x in the denominator. So 3 divided by negative 1 is negative 3, and 8 minus 3 is 5. And I don't know about you, but it was much easier to use substitution on this simplified expression. And that's why we have to simplify expressions. Level up. What now? There are 3 terms in the numerator. We cannot just cancel that 2 and 2. Remember, because we first have to get an answer there. There are invisible brackets around this expression. So we have to use a distributive property. In other words, we are going to divide each term by 2x or multiply each of these terms by 1 over 2x. And then we will simplify each expression separately. So the first expression is 4x because the x squared divided by the x1 is an x. Now be very careful here. Some learners say this is 0. Guys, a number divided by itself is 1. The 2's cancel, and if you cancel, it gives you 1. X and x cancel. Then 4 divided by 2 is 2. And then another mistake some learners make is they say the answer is 2x. But where's the x? The x is in the denominator. So the x stays in the denominator. So this is our simplified expression. Much easier than the top one. And that's why we simplify expressions. Level 5. How's this one different to the previous one? Okay, I see. There's negatives. Okay, I'm not going to be scared. Let's just do this. So we'll put each top term on top of the bottom term and divide them separately. Remember, this negative is going to be negative 3y. And you can put the negative there in the middle. It can be in the middle or there. That doesn't matter. Right, so negative 6 divided by negative 3 is a positive 2. Y to the power of 4 divided by y to the power of 1. The 4 minus the 1 gives you y to the power of 3. And be careful here. A negative divided by a negative is a positive. And then 3 divided by 3 is 1. Y divided by y is 1. Because a number divided by itself is 1. And there is our answer. So let's think about this. At the end, let's use critical thinking. Different methods to evaluate the expression. Which method do you prefer? So here is Zoot. He wanted to evaluate this expression. So in other words, we chose x to be, or y to be 10. So let y be 10. And then we'll substitute this 10 for y. So he used that expression. He substituted the 10 there and the 10 there and the 10 there. By the way, this will work. Y cannot be 0. That's the only condition, yeah? Remember that. And then that's 120 and then 121. And we can change this this improper fraction to a mixed number. A lot of steps. Okay, what is Snoot going to do? Remember, he always wants the fastest method. He is simplifying this quickly. He says, okay, y squared divided by y is just y. So I'm just going to write 10 there because y is 10. 2y divided by y is just 2. So I'll just write the 2 there. 1 divided by y is just 1 over 10. And then that is 12 and 1/10. That was fast. So do you see, guys, if you simplify an expression before you evaluate the expression, the amount of calculations that you have to do is much less. So it's really worth it to be able to simplify the expressions. Well done, you two. You helped me a lot today.